In this section, we are going to start looking at solving rational inequalities. So these are going to be like the rational equations that we were solving, except for instead of having an equal sign, we're going to have a greater than or less than sign. Now, this is going to change the way that we solve these equations quite a bit. Because I'm going to write something down here just to show you the difference here that you may not want to write down because it's incorrect. But if this were an equal sign, well, we would just get common denominator. So we'd multiply by 4 by x. 4 minus x here and here. And then we would cancel out those denominators. And we would get x minus 5 is greater than 0. And so we would have this, we'd solve it, we'd get x is greater than positive 5. Now, here's the problem with that method. If I plug in positive 5, or not 5, we don't want to use 5 because that'll give us 0. Let's use a number bigger than 5. So let's plug in 6. So if I plug in 6, I do 6 minus 5 over 4 minus 6, and that is going to give me 1 over negative 2, which is negative 1/2. That is not greater than 0. So I solved it the same way I was solving rational equations, but my answer was incorrect. So we are going to have to do something a little different for these types of problems. Actually, quite a bit different, really. So with rational inequalities, we cannot get rid of the denominator here. And so rational inequalities is going to require us to use something called sign analysis. So we're going to go through how to do that here. So the first thing you want to do when you're solving rational inequalities is you want to move everything in the equation or in the inequality to one side so that it's either greater than or less than 0. So in this particular case and in all of the questions we're going to look at today, that is already done for you. So here, everything is over here on the left-hand side. Everything is already combined, and we're looking at this being greater than 0. So whenever this is the case, the first thing we want to do is we want to look for the numbers that would give us 0, either in the numerator or denominator. So I'm going to say x minus 5 equals 0, so of course that would be x equals 5. And then I'm going to say 4 minus x equals 0. So if I add that x over here to the other side, 4 equals x. And so these are what are known, well, I don't know if we call them these critical values if they're not a derivative. It's calculus terminology. But these are the important points that we are going to be looking at. If this equation is going to change signs, it is going to happen at 5 and 4. Okay, so I'm going to make myself a number line here. And on that number line, I'm going to include the points 4 and 5. And that breaks my number line up into 3 sections. And so for this problem, I'm looking for greater than 0, so I'm looking for a positive answer. And so in this case, I want to know which section here is going to give me a positive answer. 4 and 5 should be the numbers where if it's going to, the value of the equation changes from positive to negative or negative to positive. So I'm going to pick a number somewhere here below 4 to plug in to test to see if I get a positive or a negative number. So for example, I could pick 2, or I could pick 0, or I could pick negative 1,000. But any number less than 4 I can use to plug in here. It really doesn't matter what number you pick. Any number below 4 should give you not the same value, but if it's negative for 0, it should also be negative for 2. So I'm going to choose 2 here. So 2 minus 5 over 4 minus 2 is going to give us negative 3 over positive 2, and so we get a negative answer here. All we really care about is whether it's negative or positive. We don't care about what the value actually is. Because what we want to know is what makes this equation or this expression greater than 0. What makes it positive? Between 4 and 5, my numbers that I can plug in are a little bit more limited. There's no whole numbers I could use there. I'm going to use 4.5. So 4.5 minus 5 over 4 minus 4.5 is going to give us negative 0.5 over negative 0.5. And of course, negative over negative here. Numbers are running away from me there. I don't want to go back. So I can make it move back down. Nothing seems to be working here. There we go. Let's see. Yeah, let's move this back down here. And so negative divided by negative here is going to give me a positive answer. So I get a positive answer right here. And then for the last section, I've got to choose a number here that is greater than 5. So it could be any number bigger than 5. It could be 6, 7, 8. It could be 1,000. It could be 1,000,000. 6 is an easy number to try here. So I'm going to do 6 minus 5 over 4 minus 6. So you're just plugging in 6 for your x's. And that is going to give you 1 over negative 2, which in this case is negative. Right here. And so we are looking for where the function is positive, and that only happens here in this middle section right here. So whenever we give our answer, we can give our answer two ways. We can either say 4 is less than x less than 5. Notice I used less than signs here. I use those less than signs because I do not have an equal or equal to sign right here. Also, if I do have an or equal to sign, then I could use the or equal to here, although you got to watch out for the denominator. So, so the other way I can write this here is using interval notation. I could say 4, comma 5, so from 4 to 5. Again, using those parentheses because 4 and 5 are not included. If I plug in 5, I'm going to get 0. If I plug in 4, I'm actually going to get undefined because I have a 0 in the denominator. So these, either one of these right here, this one or this one, could be our answer depending on whether you're using inequality or interval notation. All right, now these can be a little bit confusing at first, so let's do another problem, and I think as we do some more, it'll help a little bit. And so what we want to know here is we want to know what is going to give us, in this case, a number that's less than or equal to 0. And if that number is less than or equal to 0, that means it's negative or 0. But as we will see, that will not be the most important. Now, we're going to do the same thing that we did for the last problem. We want to know any of the values that would give us a 0 either in the numerator or the denominator. So x minus 3 equals 0, so that would be x equals 3. We've got x plus 2 equals 0, so that would be x equals negative 2. And then we've got x minus 4 squared equals 0. If you square root both sides, you'll just get x minus 4 equals 0, so x equals 4. Okay, so I'm going to show you a couple ways to do this problem. First, we're going to do the problem like we did the last problem. We're going to put our numbers on a number line here. And so whenever we do that, make sure you put them in order, because if you do not put your numbers in order, then you are not going to get the correct answers. So we need negative 2 down here, we need 3 up here, and then we need 4 up here. And so this is going to split our number line into 4 different sections. So what we're going to do is we're just going to pick a number from each section and we're going to plug it in. So this section down here, we're looking for any number less than negative 2, so I could maybe use negative 3. And if I do that, negative 3 minus 3 times negative 3 plus 2 over negative 3 minus 4 squared. This is going to give us negative 6 times negative 1 over negative 7 squared, and that is going to be positive 6 over positive 49, and that is a positive answer there. All right, between negative 2 and 3, I need to pick a number. Easiest number to pick here is 0, but you could use negative 1 and 2. Those are all pretty simple as well. So if I pick 0, 0 minus 3 times 0 plus 2 over 0 minus 4 squared is going to give us negative 3 times 2 over negative 4 squared. So that ends up giving us negative 6 over positive 16. Negative over positive is going to give us a negative answer. In between 3 and 4, I don't have any whole numbers that I can use, so I'm going to use 3.5. So I would have 3.5 minus 3 times 3.5 plus 2 over 3.5 minus 4 squared. Now, your numbers are not as easy to deal with here. So you've got 0.5, and then you've got 5.5, and then you've got negative 0.5 squared. And remember here, you really don't care about what the answer is. You don't care about what the number is. You just care whether this is positive or negative. So think of it this way. If you've got positive times positive in the top, you're going to get a positive. And if you've got negative squared in the bottom, you'll get another positive. So that means you'll get a positive for this section here. So you don't actually have to plug that into the calculator and find it. You could use the calculator if you want to go move a little bit quicker, but it still takes a little while even to type that in. Last, we have to look for something larger than 4, so 5, 6, 7, 8, whatever you want to pick here. I'm going to just go ahead and pick 5. Typically, smaller numbers are easier to deal with, so 5 minus 3 times 5 plus 2 over 5 minus 4 squared is going to give us 2 times 7 over 1 squared, and that is going to be 14 over 1, which is a positive right here. And so the answer to this question needs to be any value that gives us a negative or 0. And we can see here that we're only getting a negative value right here between negative 2 and 3. And so whenever we do this, in this case we have an or equal to. We do have to be really careful because there is an excluded value for this function. You cannot have a 0 right here in the denominator. So that means x cannot equal 4 for this particular problem. So even if we have an or equal to sign here, if 4 was part of our answer, we could not use 4. Because 4 is going to give us a 0 in the denominator. In this particular case, it's not part of the answer, so it's really not a big deal that we have to consider, but it could be if we had a different problem. So our answer for this would we could either write it negative 2 is less than or equal to x less than or equal to 3, or we could use interval notation and use a bracket, negative 2 to positive 3, like this. So those are our answers. Now, I told you that I'm going to give you a second way that you can do this. This is a way we do something similar to this in calculus whenever we're looking at derivatives. So I am going to show you another way that is a little bit of a shortcut on this problem. And I always use this method, but I wanted to show you how it works this way first. I always use this method. So the beginning of this method is just the same as it was for the other problem. You're going to set all of your factors equal to 0 and find these points here. And so you would start with the number line, just like we had on the last problem. So we'd have -2, 3, and 4, or I guess it's the same problem. And then what I'm going to do is I'm going to list all of my factors here on the side. So I've got x minus 3, x minus 2, and then in the bottom I've got x minus 4 squared. And so I'm listing all of those factors. I could put x minus 4 twice here since it's squared, or I can just list it squared. And I'm going to make myself a chart here. And so in the bottom of this chart, I'm going to write x minus 3 times x minus 2 all over x minus 4 squared. So because we've got this broken down to where everything is multiplied or divided, we know if we multiply numbers together, if we multiply negative times negative, we get positive. Well, if we multiply negative times negative times negative, we would get a negative. If we do negative times negative times negative times negative, we would get a positive. So it alternates. If you're multiplying an even number of positives or negatives together, you're going to get a positive. If you multiply an odd number of negatives together, you get a negative. And so what we want to do is we just want to count our negatives here. So if we think of each one of these individually, it's a little bit easier. So if I plug in a number here below -2 just into x minus 3, so -4 minus 3, that gives me a negative value. If I pick a number here like 0, 0 minus 3 is going to give me a negative value. Then between 3 and 4, like 3.5, 3.5 minus 3 gives me a positive value. And then a number larger than 4, like 5 minus 3, gives me a positive value. Whenever you have linear terms like this, just terms where I've got a single x, you should see that you change either from positive to negative or negative to positive at the point that would make this value right here 0. So you see negative, negative, positive, positive. So for x minus 2, if I plug in -4 or -3 right here, I'd have a negative. If I, oh, I'm sorry, I think that should be a +2. It is a +2. I'm still going to get a negative right here. So -3 or -4 plus 2 would give me a negative. Between -2 and 3, a number -1, 0, 1, that's going to give me a positive number. And then any number bigger than that is also going to give me a positive number. You'll see that it switched from negative to positive right here at -2, which is the value that makes this expression 0. And then let's think a little bit about x minus 4 squared. It really does not matter what we plug in right here. We're going to get a positive number because we're squaring it. And anytime you square a number, you get a positive number. So I can just go ahead and put positives all the way across here without really testing any values, because it doesn't matter. Even if I get a negative, like negative, if I plug in -4, -4 minus 4 is going to be -8, but when you square it, it becomes positive 64. So that square makes everything here positive. So whenever you look at this, you've looked at each section individually, and all those sections are either multiplied or divided together. So if you do negative times negative divided by positive, negative times negative is positive, and divided by positive, you get a positive right here for the total equate, or the total expression right there. If you have an even number, of negatives, that tells you that your answer is positive. If you have an odd number of negatives, that tells you that your number is negative. So right here I've only got one negative in this section, so that would be negative. Here, of course, if you've got all positives, I didn't write that down, but if you've got all positives, then you're going to get a positive answer, obviously. And so we can see we get this same section that we got doing this the other way. If we do a lot of these, you'll see this is sometimes a little bit faster than trying to plug numbers into every single section where you actually have to plug them in. Let's try a few more problems. So here we have a problem, x squared minus 4 over x squared plus 3x minus 10 is greater than 0, and this one is not factored for us. So it is going to be easier to do this problem if we go ahead and factor it. So x squared minus 4 will factor into x plus 2 times x minus 2. And then x squared plus 3x minus 10 is going to be x plus 5 x minus 2, I believe is how it's going to factor. And so you can see these x minus 2's are going to cancel. However, I don't really want to cancel them because it might mess up my answer a little bit. So it might not. It just depends on the problem. Especially with those denominators, it's more likely to cause an error if you've got an or equal to sign, which we don't have here. But rather than plugging numbers in for each section, I want to do the chart like I did on the last problem. Before I do the chart, I have to set each one of these equal to 0. So I'm going to get x equals negative 2, x equals positive 2. I'll get x equals negative 5. Again, I'm just setting each one of these equal to 0 and solving. And then right here, x minus 2 equals 0. That's going to give you another positive 2. Of course, you don't have to list that twice. So I'm going to make myself my sign analysis chart. Make sure you put these numbers in order. So negative 5 is the least. Negative 2 would come next, and then you would have positive 2. You don't need to put other numbers on the chart. These are going to be the points where your function switches from negative to positive or positive to negative. And then I'm going to list each term right here over here to the side. And make sure that you list them individually even if they're written twice. So you're going to have x plus 2, x minus 2, x plus 5, and x minus 2. So even though x minus 2 is the same, you've got to list it twice. And so we're going to make ourselves a chart here, and then in this section right here is where we'll put x plus 2, x minus 2, x plus 5, x minus 2. So the answer goes here in this bottom row. So let's split up what we've got here. So if I pick a number below negative 5, so a number below negative 5 would be negative 6. Negative 6 plus 2 is going to give me a negative. Between negative 5 and negative 2, like negative 4. Negative 4 plus 2, that gives me a negative. Between negative 2 and 2, like 0. 0 plus 2 gives me a positive. And then any number bigger than that is also going to give me a positive. Notice you're switching from negatives to positives right here at negative 2, which is the value that would make this expression 0. For x minus 2, if I pick negative 6 minus 2 is definitely a negative. Between negative 5 and negative 2, maybe negative 4. Negative 4 minus 2, definitely a negative. Between negative 2 and 2, 1 falls between there. 1 minus 2 is negative. And then anything larger than 2, like 3 minus 2 is positive. So you can see we switched from negative to positive right here at 2, which is the value that gives you 0 for this. You've got x plus 5, so if you have negative 6 plus 5, that gives you a negative. If you have like a negative 3 that falls in between negative 5 and negative 2, that's going to give you a positive. And then any number larger than that also gives you a positive. And then this last row right here before we do our answer, x minus 2 is the same as this line right here. So we can just copy that one more time. And now we're looking for the answer. So if I've got 1, 2, 3, 4 negatives, that's an even number of negatives. So that's going to give me a positive value overall. Right here I've got 1, 2, 3 negatives. That's going to give me a negative value overall. Right here I have 1, 2 negatives, which gives me a positive. And then I've got 1, 2, 3, 4 positives. And of course that's got to give you a positive because there's no negatives there. So we are looking for, in this case, where our expression is greater than 0. So we are looking for positives. So we have several sections where this answer would be positive. We have anything less than -5. I'm not using the or equal to because I did not have an or equal to with my answer. And x, let's see, -2 is less than x less than 2. That's this section here. And then we also have anything larger than 2. So x is greater than 2. You do have to write this separately, even though it looks like it's positive all the time above -2, because right there at 2, you're actually going to get 0, and this is greater than 0, so it can't include 0 here. If we write this in interval notation, it would look like this: -infinity to -5, and -2 to 2, and 2 to infinity here. So either one of these here could be your answer depending on what kind of notation you're using. Let's move on. I think we've got 2 more that we're going to do. So if we look at this particular equation, we've got to factor, and when we factor, we'll get x plus 3 times x plus 1 over x plus 3 times x minus 3. And again, we've got these factors right here that will cancel, and it is okay to in a way, it's going to give you most of the answers if you cancel. The only problem is it may give you a value, it may cause you to miss an excluded value if you do that. So we're not going to cancel here. And so if we set each one of these terms equal to 0, that means we would have x equals -3, x equals -1, and then x equals -3 again right here, which we don't have to list twice, and then here we'll get x equals +3. So if we put those on our number line, we've got -3, -1, +3, and then I'm going to list all my terms here. So x plus 3, x plus 1, x plus 3, x minus 3, and then, if it's all right with you guys, instead of writing that whole thing, I'm just going to put answer, the total expression. Not like you can protest, you're just watching a video. Alright, so if we're checking each section, if we pick a number below -3, right here, like -4, -4 plus 3 is negative. And then between -3 and -1, maybe like -2, -2 plus 3 is positive. And then any number larger than that, like here we have 0, 0 plus 3 would be positive and positive. Here we've got x plus 1, and we would have here -4, that would give us a negative. Here this is going to be negative, positive, positive. Notice I did that really quickly because I know it's going to switch right here at -1. Anything bigger than -1 is going to give you a positive. Anything smaller than -1 is going to give you a negative there. X plus 3, I'm just copying the same line. Negative, positive, positive, positive. And then for this last one, it's 3 would make this 0, so it's going to be negative, 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 positive right here. Any number below 3 is going to make that a negative value, but any number above 3 will make this a positive value. So, again, we're doing our sign analysis. We've got 4 negatives here, so that would be a positive. An even number of negatives is going to give you a positive. Here we also have an even number of negatives, so we'll have a positive here. We've got a negative here, and then positive here. And so this particular equation wants us to find where the graph is greater than or equal to 0. So it's looking for positive sections. In this case, you can have the equation equal to 0, but you have to watch out for excluded values. So if you're looking in your denominator here, x cannot equal negative 3 and x cannot equal positive 3, because if you plug in either one of those values, then you're going to get a 0 in the denominator, which makes the expression undefined. So that means even though we have the or equal to sign here, we cannot include negative 3 or positive 3 as part of our answer. So if we're writing our answer for this, our positive sections are here, here, and here. And so to write our answer in this case, I'm going to use interval notation first this time. I can go from down here, over here is negative infinity, up here is positive infinity. So I can go from negative infinity up to negative 3, but negative 3 is an excluded value, so I cannot include negative 3. And then from negative 3, again not included, to negative 1, I have positive values. And right here, negative 1 is not excluded, and I've got an or equal to sign right here on my inequality, so I can put a bracket with that one. And right here, from 3, I cannot include 3 because it's an excluded value. Up to infinity, I will have a positive value there. So I can write it this way. The other way I can write is I could say x is less than negative 3, and negative 3 is less than x, less than or equal to negative 1, and x is greater than 3. You could write it either way here as your answer. I think interval notation is a little bit easier on these, but you may not. All right, let's do one more just to see that we've got this. So here we've got 8x squared plus 4x is less over x minus 4 to the third is less than 0. So we want to factor first. So in that numerator, I could factor out a 4x, just the greatest common factor there. And so x plus 1, I'm sorry, that's not x plus 1. That would be 2x plus 1 would be left in that numerator. And then in the denominator, we would have x minus 4 to the third. And this is less than or less than 0. So right here, when I've got 4x, when that equals 0, I'd have to divide by 4. So x equals 0 is one of the numbers I need to test in my sign analysis. Then I've got 2x plus 1. So if I set that equal to 0, I'll subtract my 1. 2x equals negative 1. And then so x equals negative 1/2. That's another number that needs to go on my sign analysis. And then this one in the denominator is simple. X minus 4 equals 0. So x equals 4. So these are my three numbers for my sign analysis. So I'm going to put that on my number line. I'm making sure that I put my lowest value first. And then move to my higher values. And then I'm going to list everything over here. So I've got 4x. I've got 2x plus 1, and I've got x minus 4 to the third power. And then, so I don't have to write as much, I'm just going to put answer here, but of course I mean this entire expression. Now, when you raise something to the third power, it's not automatically positive, so you do have to think about that one there. If you had a square right here, you wouldn't have to think. You could just go ahead and put positives in that section. So for 4x, if you plug in a negative number, like a number below negative 1/2 or below 0, then you're going to get a negative value for this, and then you'll have positives here. For 2x plus 1, if you plug in a number below negative 1/2, like negative 1, 2 times negative 1 is negative 2 plus 1. That'd give you a negative. But then numbers larger than negative 1/2, like maybe negative 1/4, 2 times negative 1/4 would be negative 1/2, and then you would add 1. You would actually get a positive right there. And then any number larger than that is also positive. Here, I've got x minus 4, so I'm really just thinking about x minus 4 because if I take a negative number and raise it to the third power, it's still going to be negative. If I take a positive number and raise it to the third power, it's still going to be positive. So x minus 4 is really all I've got to think about. And if I plug in a number below negative 1/2, that's still going to give me a negative here. Same thing here. negatives all the way up until you get to 4. At 4, 4 minus 4 is 0, of course, so numbers larger than 4 are going to give you a positive. So now you can look through. 3 negatives here means a negative. 2 negatives here means a positive. 1 negative here, that's an odd number, so you get a negative. And then, of course, all positives is going to give you positives. This particular problem asks us for less than or equal, or not less than or equal to, just less than 0. So we're looking for negative for our answer. And so that means that we're looking at this section and this section. And so for our answer here, if we're using interval notation, we'll have negative infinity up to negative 1/2 and 0 to 4. I think it's easier when you don't have the or equal to. You don't have to worry about excluded values because you're not going to include any of them anyway. If you want to write this in inequality notation, x is less than negative 1/2 and 0 is less than x less than 4. And so those are your answers for these. For this assignment, you've got a worksheet that I want you to do. So you're only doing certain problems on that worksheet. Don't try to do the whole thing yet because you won't be able to do that yet. And you can turn that in on Canvas for me.